Hey everybody, thanks for joining me in my video. We are taking notes in our AVP workbooks on page 147. And what we're looking at today is independent and dependent events dealing with probability. So the first thing I want to point out to you is that it's very easy to get independent and dependent confused with mutually exclusive and non-mutually exclusive. I want to tell you what the biggest difference is. When we are looking at mutually exclusive and mutually non-exclusive, like we did in lesson 3, we are looking at one trial. And the connector word is always or. So for instance, we are choosing our breakfast. Will it be a bagel or will it be cornflakes? So we're only doing one thing. There's one event happening and it's either A or B. So we now switch to independent and dependent where we have more than one trial or more than one event is happening, and we're looking at a connector word of and. So we're looking at doing two things. We're going to spin a spinner and we're going to draw a card. So two events are happening and we're looking at the probability of spinning a red and drawing a 7. So two things happening and the connector word is and. So we're going to start off here with an investigation so that we understand exactly what is going on here. So it says one card is drawn from a deck of cards and is replaced. Those words, replaced, are going to be very important. A second card is then drawn. So notice that when you draw your first card, there's 52 cards to choose from. And you pick a card and you put it back. When the second trial happens, when you're drawing your second card, there is still the full deck to draw from. All right, we've got event A, and that is the first card is a heart, and event B, the second card is a heart. So we're going to determine the probability of A, determining the probability that we draw a heart. So probability of drawing a heart would equal 13 out of 52. And of course, we can reduce that down. We always want simplest form, 1 out of 4. Now, basically, remember, we're saying 1/4 of the cards are hearts. Okay, we draw that heart, we take a look at it, we put it back in the deck. What is the probability that the second card is a heart? So now we're working on the second card. So again, we think, well, how many cards are in the deck? How many things could happen? Possible outcomes. 52 possible outcomes. How many of those are favorable? How many of those are hearts? 13 out of 52. And again, it's 1/4. So the probability of event B does not depend on what had happened with event A. Events A and B are called independent events. Okay, and then you've got a little definition there. Independent events. Two events are independent if the knowledge that one event has occurred has no effect on the probability of the other event occurring. All right, investigation of dependent events. One card is drawn from a deck of cards and is not replaced. A second card is then drawn. consider the following events. So same events as we had in the first investigation. We're going to determine that the first card is a heart. So possible outcomes is 52. 52 things could happen when we draw our card. How many of those are favorable, or how many of those are hearts is 13. Well, this is all starting off pretty much like our first investigation. But watch what happens now. Now we're looking at the second card is a heart. So what we have to do here is remember that one card has already been drawn and it was not replaced. And when we do this, we have to assume that it was a heart already. So here when it says, why is it not possible to determine the probability of drawing a second heart? Well, it's left up in the air a little bit, because remember, we're now dealing with 51 cards, and with one card missing, we don't really know how many were favorable. So it's impossible because we don't know which card was removed from the deck. Now, there is a way to deal with this. So this investigation is not saying that this is impossible, but it wants us to think through it. So it says the probability of event B depends on whether or not event A occurred. So that what happens on the second card depends on what happened with that first card that was drawn. Therefore, A and B in this case are considered to be dependent events. All right, so let's take a closer look here at dependent events. And here's our definition. Two events are dependent if the knowledge that one event has occurred changes the probability of the other event occurring. So example 1, all we're going to do here is classify the events as dependent or independent. So please hit pause and give these ones a try. So with A, the experiment is rolling a die and tossing a coin. The first event is rolling 2 on the die, and the second event is tossing tails on the coin. These two events are independent. Because what happens on the die has no effect on what happens on the coin. So they're independent of one another. And with B, the experiment is choosing 2 cards without replacement from a standard deck. So again, we really have to watch with the card questions. Do they replace the card or do they not replace the card? So here they do not replace the card. The first event is that the first card is a king, and the second event is that the second card is a king. So because they pulled the first card and they kept it, that changes the probability on the second card because we no longer have a full deck. And with that one card missing, it's going to change our numbers when we set up our fractions. So this is dependent. Because one card was drawn and not returned, it affects the second draw. The second draw depends on the first draw. And with C, the experiment is choosing 2 cards with replacement from a standard deck. So with replacement, they take one card, they look at it, They put it back in the deck. The first event is that the first card is a king, and the second event is that the second card is a king. Here we're looking at independent events. Because the first card is returned to the deck, it means on the second draw, you're dealing with a full deck of cards. No cards are missing. So what happened on the first draw has no effect on the second draw. Now, this next page is all about conditional probability, which we're going to leave for now. And we're going to move on here to the multiplication law for dependent events. So I want to start off by sort of reminding you that you already know this little rule. When you see the word and, we know that we should multiply. So whether we're dealing with dependent events or independent events, they will always have the connector word of and. We're looking at the probability that A and B happen. So we'll always be multiplying when it comes to dependent and when it comes to independent events. And in our workbook, we're going to have two different formulas. So we see that the formula right here that is for dependent. And if we flip ahead a page or so, now we see this one that is independent. But take a look at them. Here we have the symbol for intersect, which is and we are multiplying. So probability of A and B, we take the probability of A and we multiply by the probability of B. So pretty straightforward. And means multiply. And then they show it a little differently here for dependent. But I think when you're doing questions with and, you should always be thinking about this formula anyway. We've got the intersect, which is and. So we're looking at probability of A and B. So and is multiply. We're going to take probability of A. We're going to multiply by probability of B after A has already occurred. Every time you're doing an and question, take it on with this strategy. Just probability of A times probability of B after A has already happened. Whether you're looking at dependent or independent, this one will save you in both cases. So example 2. 2 cards are drawn, and again, so important to watch for this when we're dealing with cards. 2 cards are drawn without replacement from a standard deck of 52 cards. Determine the probability of the following events. So when we look at this with words, both cards are red. That really makes it sound like there is one event happening. It's really important that you break this up into 2 events. 2 cards are being drawn and we deal with each card separately. So my planning step is going to help me break it up into 2 separate events. I'm going to say I'm looking at the probability of red, and on the second card, probability of red. So split it up to be 2 separate events, even if the words make it sound like one event. All right, I'm picking my first card. So 52 things are possible. So there's 52 possible outcomes. That's our out of number. And 26 out of 52 are red. So there's the probability for your first draw. And means multiply. Now I'm on my second draw. So again, I have to think about what we set up here. When I'm working on my second event, I have to remember the first event has already taken place. So I'm looking at the probability of drawing a red. Remember, on the first card, I took my card out of the deck and I put it in my pocket. I did not put it back in the deck. So possible outcomes now is 51. There are 51 cards in the deck. And then here's the little catch part. You have to assume that we were successful on our first draw. Because remember, we're looking at red and red. So we are thinking, yeah, first card was red. So when I go to draw my second card, there are only 25 red cards left because one is already gone. I'm going to multiply these in my calculator because then it will simplify the fraction for me at the same time. And I get 25 out of 102. So theoretically, if I tried this experiment 102 times, I would be successful 25 of those times. All right, so on B, neither card is a club. Again, that sounds like one event, but there are two cards being drawn. So let's break it up into two different draws. Probability of not clubs on my first draw and probability of not clubs on my second draw. You really have to think very specifically about each draw. So on my first draw, 52 possible outcomes, and 39 of those are not clubs, and is multiply. Drawing my second club, or my second card, but because I kept a card, I'm now looking at only 51 possible draws. And I have to assume that I was successful, that I did get a non-club. So on my first draw, there were 39 non-clubs available, and now there will only be 38 available. Multiply that in your calculator, and I believe that comes to 19 over 34. And no longer will I take time to go over the deck of cards. It's been posted on Classroom so that you can print it off or you can look back at it yourself to see where the numbers are coming from. So certainly, if you're not familiar with the deck of cards, print it off and have it sitting beside you as we go through this unit. Question C, the first card is a king and the second card is a 5. So our planning or our setup step, probability of a king and probability of a 5. So really walk yourself through this. You're sitting there, there's a deck of cards. I'm going to make my first draw. There are 52 possible outcomes. 4 of them are kings. And means multiply. Now remember, I didn't replace the first card, so on my second draw, 51 possible outcomes, and 4 of them are 5s. And our final answer on this one, 4 out of 663. And then with D, one of the cards is a king and the other is a 5. So this one's a little tricky because they don't tell us. It's that one of those ones where, oh man, it feels like something is missing here. It's a little bit ambiguous. They didn't give us enough detail. So the detail that's missing here is the order. Which card is the king and which card is the 5? So let's just give ourselves a little note for this type of question. when order is not specified, include all possible orders. So what we actually have here is an or type of question. So it could be the king first and then the 5, or it could be the 5 first and then the king. So I'm looking at drawing a king on my first draw. There are 4 kings out of 52 cards. And is multiply. Now I want to see, can I draw a 5? And I've already drawn a king. So now I only have 51 cards to pick from, and 4 of those would be the 5. Now or means add. And so right here we are at a whole new draw. This is not drawing a third card. This is a new scenario, and we're saying on our first draw, what is the probability of drawing a 5? So 52 possible outcomes. 4 out of 52 are 5s, and means multiply. And when we go to draw our second card, there's 51 possible outcomes, and 4 of those are kings. So I want to point out to you here, why I feel it's important. This is your thinking step or your planning step, but it also allows you to really think specifically about drawing that king as your first card. And means multiply. Now we're drawing the 5. It makes you think. This sort of planning step allows you to go from your thinking stages and translate it directly into mathematics. So there's a lot of stuff to be punched in here. You could put this in your calculator all at once. I decided to do a little bit of grouping. I multiplied these first to get 4 out of 663. And this comes out the same, 4 out of 663. My final answer, 8 out of 663. So it's kind of nice when we can get some old knowledge and tie it in with some new knowledge, all that planning step, and means multiply, or means add, all stuff that we've seen a little bit of before. So in our workbook now, it switches and it says, we're now going to deal with independent events. And it shows you a different formula. But I don't think of these independent any differently than dependent. I still think about and means multiply. This will be probability of A times probability of B. And even though it doesn't have the after A, I still always think about it as A has already happened. And that way, anytime I'm doing an and question, it will feel the same. So for example 3, 2 cards are drawn, this time with replacement. Determine the probability of the following events. So for A, both cards are red. Still really important that we treat this like 2 different events. So the first card, we're looking at probability of red, and second card, probability of red. So I'm drawing my first card. 26 out of 52 cards are red, and means multiply. Now I'm drawing my second card. Because I replaced the first card, I drew the card, I looked at it, I put it back in the deck. We're drawing from a full deck of cards, 52 cards. And how many are red? 26. And we end up here with 1/4. Now notice my thinking, my strategy, my planning. It didn't seem any different than what we did in example 2. So even though the first example was dependent, this example is independent. An and question is an and question. Treat them all the same. Okay, in B, probability that the first card is a king and the second card is a 5. So the first card is a king. 4 out of 52 cards are kings. And means multiply. Now I've drawn a card. I put the card back in. So on my second draw, 52 cards are possible. 4 of them are 5s. And this comes out to be 1 out of 169. So just very simple. And means multiply. And when you're working on your second fraction, always remember and think about what are you picking from. Remember, 1 has already been drawn. And think about that card's already been drawn. And in this case, it's been replaced. And then think about that second fraction. So here's another one of those ones where it feels like, something's missing here. One of the cards is a king and the other is a 5. So remember, this can happen in 2 ways. So we'll say this can happen in 2 different ways, or we'll say different orders. So remember, if they don't specify the order in the question, we need to do all possible orders. So it could be the king first and the 5 on the second draw, or it could be the 5 first and the king on the second draw. So let's go through each one of these scenarios. Now remember that this planning step helps us set up our math because we're going to say probability of a king and means multiply, probability of 5, or means add, probability of a 5, and means multiply, probability of a king. So I want you to pause and see if you can finish filling this one in now that we've got our planning step there. So I'm making my first draw. 52 possible outcomes, and 4 out of 52 are kings. And is multiply. Now think about the fact that you've already drawn a card. I drew the card, I looked at it, I replaced it back in the deck. So I'm drawing from 52 cards, and 4 of those are a 5. Or means add. Drawing a 5 on my first card, and is multiply. Drawing a king on my second card. It's 1 over 169 plus 1 over 169. And my final answer, 2 out of 169. So we are about halfway through lesson 4. This is where we will get our first practice assignment. So make sure that you are practicing with questions 1, 2, and 6, and that you use my solutions to check your answers. Good luck with your assignment and have a great day.